Hello, today we're going to look at properties of logarithms. So remember that logarithms are exponents. So the rules of logarithms come directly from the rules of exponents. So we'll let u be log base b of x and v be log base b of y. Converting these into exponentials, we get that x equals b to the u and y equals b to the v. So if I want to multiply x and y together, it's going to be b to the u times b to the v. Using rules of exponents, that gives me b to the u plus v. And then I'm going to take this guy, I'm going to ignore the middle part, and I'm going to convert this into a logarithm. So my exponent, u plus v, equals log base b of my x times y. So my last step here is to replace what u and v are. So property 1 is that log base b of x plus log base b of y equals log base b of x times y. So if I'm adding two single logarithms, then I can combine them into one logarithm by multiplying the arguments. Similarly, we'll look at x divided by y. That gives us b to the u divided by b to the v. Using rules of exponents, we get that's b to the u minus v. Again, we're going to ignore this middle part and translate this back into logarithmic form. So u minus v equals log base b of x over y. And then my last step again is to replace what u and v are. So property 2 is that when I subtract two logs, I get a single log where I'm dividing the arguments. Notice the one that I'm subtracting is the one in the denominator. The next thing we're going to look at is x to the n. So that's b to the u to the n. Using rules of exponents, that's b to the u times n. And again, we'll ignore this middle part. We'll translate this into a logarithm using the base b. Right, I've got two exponentials here, so using log base b. We get that u to the n, the exponent, is equal to log base b of the left-hand side, which is x to the n. Again, replacing what u is, we get property 3. N times log base b of x equals log base b of x to the n. So what we do is we think of it like just moving the exponent down as a coefficient. Property 4 is that log base b of b equals 1. So if the argument is the base, then it's equal to 1, and that's because b to the 1 equals b. Property 5 is that log base b of 1 equals 0, no matter what b is. Again, this comes from the fact that b to the 0 is always 1. The following isn't listed as a property, but I really think it should be, and this is that log base b of b to the n equals n. And if we translate this back into exponentials, it makes perfect sense. This is saying that b to the n equals b to the n. Okay, so if I have the argument, if I can write that as my base to a power, then all it equals is the power. So log base b of b to the n equals n. So we're going to do a little bit of work using these properties. We're going to expand a single log into multiple logs, and we're going to combine multiple logs into a single log. So first we'll expand into multiple logs. So a, log base 2 of 3x. So I look at 3x and I say, okay, is that multiplication, division, or a power? Because those are the three basic properties that we had. So we look at 3x and say, okay, that's multiplication. So I'm going to use property 1 here and split up the multiplication by adding the logs of those individual factors. So I got log base 2 of 3 plus log base 2 of x. For b, I look at the fact that I'm dividing x and 8. So I'm going to look at property 2 that says if I have division inside, I can expand it by subtracting. So I get log base 5 of x minus log base 5 of 8. log of 2x to the fourth. So here I have to be careful. It looks like I can do property 1 because I'm multiplying, but I also have an exponent. So I'm going to think of property 3 as well. But we have to be careful on the order. Right, going by order of operations, I'm going to raise x to the fourth and then multiply by 2. So when I start breaking this up, I kind of need to go backwards. So I'm going to separate them from the multiplication first. So I'm going to have log of 2 plus log of x to the fourth. Now I'm going to use property 3 and bring that 4 down in front. And that gives us log of 2 plus 4 log of x. So be careful, because I always have someone who wants to call this 4 log of 2x. But that is 2x in parentheses raised to the fourth. So that would be log of 16x to the fourth. Okay, so be really careful on your order of operations. If I brought that 4 in, that whole thing is being raised to the fourth. Okay, but it's just the x, so we need to separate it across the multiplication first. So for D, we have ln of 3 divided by xy. So I'm just going to erase what I have here. And then we have division. We also have multiplication. So yeah, we got to be careful here. If I separate it with the division, then I have ln of 3 minus ln of xy. And then xy is being multiplied, so I would add that, separate it by adding, but I have to remember that that subtraction is still there, so I'm subtracting ln of x plus ln of y. And I'd have to distribute that negative sign if I want to clean that up. Okay, so here it is with the subtraction sign distributed. So ln of 3 has a positive coefficient, that's why it's in the numerator. Ln x and ln y are both negative, so they're in the denominator. Okay. So a negative coefficient corresponds to the denominator, just like a negative exponent corresponds to the denominator. Again, the rules of logs are rules of exponents. Okay, more often than not, we're going to want to simplify into a single log, so we're going to do those ones next. So a is log base 3 of x plus 2 log base 3 of y. So this is very similar to part C that we just did. Before we can do any adding or subtracting of logs, we have to make sure that the coefficients are 1. So I can't just add log base 3 of x to 2 log base 3 of y without doing property 3 first. So between properties 1, 2, and 3, if we're simplifying, we have to look at property 3 first. So I'm going to bring 2 in as an exponent, and that's going to give me log base 3 of x plus log base 3 of y squared. Now I can add the logs, and when I add my logs, I'm going to multiply. So I'm going to multiply x by y squared, and I get log base 3 of xy squared. For B, I've got log base 4 of 3y minus log base 4 of 5. So my coefficients are already 1, so I can't do property 3. So now I'm going to look at the fact that I'm subtracting, and it's going to be a property 2. So I get log base 4 of 3y divided by 5. For C, log of 4 minus log of 3 plus log of 2. So I've got two operations here. Right, order of operations tells me I need to go from left to right since it's all addition and subtraction. So I'm going to look at this guy first and say that that is log of 4 divided by 3, because that's what subtraction means. So I'm going to take that and I'm going to add to it log of 2. So the fact that I'm adding them now means I'm going to multiply. So I'm going to have log of 4/3 times 2. But I know what that is. That's just 8/3. So I have log of 8 divided by 3. Right, I always have someone who will do these guys first and say that's log of 6, and then do log of 4 divided by 6. But be careful, again, order of operations is always the prevailing case, and we would have to do that subtraction before that addition. Okay, so I can't do those two together first. So D, 3 log of 2x minus 2 log of 3y. So again, before I can do that subtraction, I need to bring those coefficients in, because that property, number 2, doesn't have any coefficients in it. So the coefficients have to be 1. So I'm going to bring the 3 in, I'm going to bring the 2 in. And again, we have to make sure that we're cubing the entire 2x. So it's not just log of 2x cubed, it's log of 2 cubed x cubed. And 2 cubed is 8. Oops, that's a 3. Minus log of not 3y squared, but 3 squared y squared. So 9y squared. And now with the subtraction, I'm going to divide them. So I get log of 8x cubed divided by 9y squared. So now we're going to find the value of the given logarithm. So now we're going to look at properties 4, 5, and then that note that I put down, which we can kind of think of as a property 6. So A says log base 3 of 1. So log base b of 1, no matter what b is, if a 1 is inside the log, we get 0. Okay, because again, anything to the power of 0 is 1. Log base 2 of 2, my base is my argument. That's property 4, and that tells us that the log is 1. And again, I know that that's true because 2 to the 1 equals 2. Okay, log base 4 of 16. So this is not properties 4 or 5. My argument is not 1 or my base. So that's going to be, again, that kind of property 6 that we're going to look at. So 16 isn't my base, but it is a power of my base, and that's the important part. So 16 is 4 squared. So I'm looking at log base 4 of 4 squared, which is 2, because 4 to the 2 equals 4 to the 2. So again, I'm just looking at my exponent. So log base 4 of 16 is 2. For D, log base 6 of 6, again, my argument is my base, so that's property 4, and that's equal to 1. Log of 1, so remember if there's no base, it's base 10, but it doesn't matter because my argument is 1, so the logarithm is 0. And again, that's property 5. And then our last one, log base 3 of 81. Again, 81 is not 1, so it's not property 5. And it's not my base, so it's not property 4, but it is a power of my base. So 81 is 3 to the 4th. So I'm looking at log base 3 of 3 to the 4th. And again, that is just my exponent. It's a terrible looking 4. So I get that it's 4. Okay, so make sure that you read through the book and let me know if you have any questions. Thanks.